I'm a university teacher, and teachers, we can give lessons like in a classical way. So we start with the story of viticulture. So from the ancient, early Neolithic times, we have some remains of grapes. Then they came the Egyptians, then the Greek, then the Romans, then the Middle Ages, and have some very nice idea of how viticulture was. But in all these 5 moments, all they shared one thing, that the vines were grown in their own roots. Okay? So this is the way everything was until some small insect arrived. They had to graft things, they had to do things. Okay? This is the way I should have explained things in the past. But now, we are more modern, so this is the same story made shorter. Everything was happy on Earth. We were all happy. Suddenly, a bad bug came. Then super rootstock came. And then we are happy again. So this is, for young generations, the way of explaining the history of viticulture. But of course, the moment where we changed all the viticulture because of the arrival of phylloxera implied three different parts. On one side, we had the vinifera that more or less they knew after 2,000 years. They knew a bit about them. They had to learn on grafting, and that was a very, very, very big challenge, and we have wonderful drawings from the time when they were using different modalities of grafting. And as Kay said, we are trying to work in cooperation with Sarah Curson's team here on the understanding better what's going on with grafting. And also we have the rootstock and the interaction between the rootstock and the variety. So in fact, it's a complex topic, the one of rootstocks. We have like 150 years of breeding, very active at the beginning, not so active in the last 100 years. And we have quite a lot of experience because people have been trying to learn on rootstock evaluation. Okay, and now if I went back to the title of my conference, it was like a kind of adaptation to climate change. And in this new situation, the question is again super rootstock coming to help us for this climate change condition? And the answer is that super rootstock is here, and of course it can be part of the solution. You know a lot about they can modulate response to water scarcity. They can help to many things. They can lower pH, that is very important in warm regions. So we have this super rootstock trying to help us. But the question is that it's not an easy subject topic to investigate. I will start with one example of research we published in 2019, where we evaluated with 2 varieties, Syrah and Tempranillo, with 12 rootstocks. Okay, so we have the typical tables you can read in the papers. That's very nice. We also did some component analysis to see how the rootstock group and which behave similarly. But the question is that this work, that is only a single paper, and I don't know how many dollars or euros costed, as Roland said, but the point is that there were 12 rootstocks with 2 varieties, with 3 replicates, with 10 vines per replicate, with 4 years of research, which makes measuring yield in 2,880 vines. It's quite a bit. So you need people doing the work, of course. But that's not all, of course. This is quite a lot of work, but if you go to the sampling and to the quality, you have 3 sampling dates, you have 2 subsamples to measure the basic quality, the phenolic quality. So 4 years, so it's quite a lot of samples. And if you take 200 berries per sample, it's like quite a lot of samples. You have a lot of berries, more than 300. So you need a good team of samplers. So this is, I think, all the samplers deserve an applause. So please, applause for the samplers. But the question is that you are doing this work, and it's to be proud, and you are proud too now with me. But you get to the place, and, oh yes, but it's only one soil type, yeah, and only one location. Come on, and of course you and your team is like, hey, come on, after all this work. So, but the point is that it's true. It's true. It's only one site, one location. The climate and the soil are only one, and you need to learn more. So for that, we have a lot of tools, and one of them is a meta-analysis. With meta-analysis, we try to compile research done by other groups, by other teams, and trying to put it together and to understand trends that can be like more general and that we can learn faster. So with this, this is what it is. It's a question that is getting up in the research. If you go to a database, meta-analysis did not appear in the literature in the 90s, but now it's like getting higher and higher. And what we did in this work I'm presenting is to evaluate research that had been done in Spain. Okay, we could have taken research made done all around the world, but we decided to focus on research in Spain due to the climate conditions, and also because we wanted to get into the meta-analysis those works that were published not only in scientific journals, but also in like more transfer journals, on older publications, like this book that is a fantastic book with data from many places, many years, or like this type of journals, and of course scientific papers. So what did we have to do? We took all these type of journals and we read them and we put all the data in tables. So we had this data with the information on the rootstock, the yield, the years, all the information that was in the paper. We had to pull it out and try to understand what was going on. We got to a very, very big table with a lot of rows that we use for this meta-analysis. Okay, so we were paying attention to work that had already been done. So in this meta-analysis, what we use, and I will explain it very, very shortly, we were not trying to compare everything together, but to see the degree of response to the average in that experiment. So yield is bigger or smaller, and in which proportion. So this leads us to a kind of results like these ones that we see what would be here in the zero, no response. If you are on the right, is a negative response, and if you are in your right, is a positive response, sorry, and in the left, negative response. So here we have this data, and from those papers, what we had, they had all in common were yield, pruning weight, Rabat index, sugar content, and pH. We have some acidity data, but not much. We have phenolics, but only in some papers. So we decided to keep on this. So we took all this information and we prepared this kind of data. And I think they are interesting because we can see the general behavior of, in this case, Berlanderi perriparia crosses, a slight increase in yield. Berlandieri perrupestris, no changes in yield. Berlandieri pervinifera, decrease in yield, and other crosses. And we also can go rootstock by rootstock. So we did this for yield, as I mentioned. We did this for pruning weight, for vegetative growth, with the changes we observed, and also for sugar content, which is particularly relevant in a context of climate change. Okay, so we see that some rootstocks tend to provide a lower sugar content, and some others, like Berlandieri perrupestris, globally provide higher sugar content. Okay, the same for pH, with not similar, but with different trends. And I think this is a very interesting way of studying. We also could, with this data, see like the joint effects, the relation between the variables, that sometimes they were not as high as we could expect. Of course, there is a link between yield and sugar, negative. So the higher the yield, the lower the sugar, but the association is not so high. So that means that the rootstock is playing also a role in that kind of association. With all this work, we also could make like a tree of this relationship of which rootstocks behave more similarly. And we did, and I'm not explaining this because it's in the paper, also analysis to see which were the trends and which rootstocks could be more interesting in terms that they were providing lower sugar and lower pH. So they were not completely associated, they were quite opposed, so they were relatively independent. So things being here could be, in that sense, more interesting. So the role of the rootstock was shown here, and you have the article, and you can access as you know. So from this point of view, I was happy because people that was doing research in the past were satisfied with all the work they did, and also all the samples they took were I don't know, we took advantage of their work. But the point is that this process, you know, takes a lot of reading, takes a lot of time, and you can finish like this. And of course, now we are much more advanced than 5 years ago. That's incredible. But the Papa Strumpf bought a computer, found ChatGPT, and started playing things, playing games. So he said, okay, I will try if ChatGPT can help me with the meta-analysis. And I did this like on Monday, so they work. So I took a random paper on rootstocks. In this case, it was from Poland. I haven't read this, okay? And I said, okay, I will ask ChatGPT to do some things. Good morning. You need to be very polite. If you want a good answer, bonjour, Monsieur ChatGPT, Madame ChatGPT. I'm attaching a scientific paper where the influence of different rootstocks in grapevine is analyzed. I'm considering doing a meta-analysis, so I would like to extract as much quantitative information as possible. I would need you to do the following. Now, we say, okay, create an Excel file, okay, I can work, where the information the tables include is presented. Each table should be in one sheet, okay, everything organized. And the caption of the table included in the first row. Please the headings on the third row. So I can find things easily. That's very important. So, additionally, of course, he works for free. Create a first sheet with the following metadata of the article are listed in rows, very clear, and include the title, the journal, the publication year, volume pages. I heard you had some problems with your old conferences, so please hire this friend. Everything, the number of seasons, very important, and the vinifera varieties used for this. Also the location of the experiment, and if it was a pot or a field experiment. Okay, and of course I keep on asking. I told you that this is for the last, create a sheet, place it as the last one, to give you an order, where you indicate any consideration, the punctuation of the article in a 5-star scale, so like the TripAdvisor or so I have a clear idea, and if there are some figures that can be also hiding interesting information, quantitative. So this process, uploading the file and the calculation, in fact, in that video, it's doing it. It took like 2 minutes and 32 seconds, okay? So it's not bad, okay? And I uploaded, and I got the information, title, journal, publication year, volume pages, authors, number of seasons, vinifera use, location, field of port field. I obtained, this is the first table with variables of weather conditions at the experiment. This is the second table, okay, with the rootstocks that they were using and with the variables they measured, okay? The system skipped the years because I told the system that I was focusing on rootstocks, because in the original table, there were like the 3 years, like the cross effect, focus on what I told him to measure. And of course, it was like a 4 stars upon 5 in quality, the replicates were 5, 3 years, and there were some figures that could be interesting, but in fact, they were not very. So this is really like incredible, because in this case, the samples are happy, but I am also very happy because it takes really, really little. But I did this experiment for this conference because I didn't know how it would work, but it's incredible. So it changes many things, and I think that we can make more meta-analysis now. We can use these tools to make the work that all samples and that everyone did better. And we can learn faster. That was part of the title of my conference. And in the title of my conference, I said another thing, that adding up means learning faster, okay? But how much should we add to this equation? Because before, I told you, when I was speaking of this article, I told you this on the sample number and on the berry sample, but I was lying. This was not true. This is what we had to publish in 2019 and probably finish in 2018, the data. So, in fact, we have 10 years now of this information, which means more samples, which means much more berries, nearly 1 million berry sample. So this is good because we can follow the trends for Syrah and for Tempranillo. We can see some things that can be interesting, and what we can make is to see the ranking of the rootstocks. And I will only focus, and I don't want to use a lot of time on this. I will focus only yield, only Tempranillo. Okay, so this is the last time you will see Syrah. And for Tempranillo and for yield, we have for the 10 years, which was the ranking of each rootstock in terms of the highest yield. So we can see that 3309 was number one most years, only second in rank in the first of the years. Some were always in the lower part. Here you have the average. There are a lot of colors, and even I cannot distinguish them very well. But the idea is that we can see that there are some trends. And of course, and I was saying before, how much should be added to this information? Are these 10 years necessary? Because it's a lot of work, it's money, it's a lot of resources. So my question, what if I had studied this for 3 years, or if I had studied for 4 years, or for 5 years? So what I did was to combine the data in all possible combinations of 3 years, of 4 years, of 5 years, of 6 years, of 7 years. So there are like 45 possible combinations of 2 years. There are like up to 250 something combinations of 5 years. And I try all the possible combinations to see if the ranking was changing, to see if I had to work 2 years, was fantastic, 3, fantastic, 4, 5, it's tiring, okay? But in a very simple comparison, and I say this is only for yield and only for Tempranillo, so maybe if I write something about this, it will be different, the result, because these are very, very preliminary. I estimated the number of misranking. Misranking for me meant that the change in order in yield compared to the final order using the 10 years was that more than one position. Okay, if was the second and was became the third or the first, it's not a big change. So that was not misranking with this criteria. Also, and here you have that if I study 2 years, in 20-something% of the possibilities, I was doing misrankings bigger than one position. But as I went to 4, 5, 6, of course, it decreased. But this is very interesting because it meant that we have like a number to use. And if we went to a more flexible degree of misranking, that means that bigger than 2.5, so in fact it's that 3, okay? If it changes from being the 4th to being the 1st, that in 12 rootstocks is not a big change because it was productive, it will be productive. You have that for the 4th year, you have 1-point-something% of misranking. So all people in the sampling team said, okay, why am I sorting this, measuring this for 10 years? This is terrible. Okay, but this is very useful information that I would like to explore in the next years to understand how these changes and how long we have to work. I think we have to be efficient, and we have tools, and this study probably would be a good tool. Just to finish, I would like to thank all the samplers, of course. I would like to thank all the projects that provide money. I wouldn't use the. We are not so rich, so if you have money, we are open to collaboration. So if you don't, we are also open. But of course, to IVES and to the Chateau Douar-Milon for having us here, and to all of you that were very active, and you even gave an applause for the people. So thank you.